All right. 7, 8, and 9, we're going to again do confidence intervals. This one has really a whole long ton of formula to get the answer. I had to highlight 2 formulas. First of all here, when I'm doing my confidence interval, this one has a 90% confidence interval. So on my confidence interval, if the middle part is 90%, that means 1 minus 90% would be 10%. 10% divided by 2 means each of those little sections are going to be 5%. So when it was 95%, we use 0.025. If it's a 95% or a 90%, then we use 0.05. So we are first of all going to find what they call SP squared. And the formula for SP squared is n sub 1 minus 1 times S1 squared plus n sub 2 minus 1 times S sub 2 squared over n sub 1 plus n sub 2 minus 2. So, it says, a light bulb manufacturer wants to compare the mean lifetimes of 2 of its light bulbs, Model A and Model B. Independent, random samples of the 2 models were taken. Analytics of 16 bulbs, that means N1 is going to be 16, of Model A showed a mean, which is your X bar that we don't need on the first part, but we'll need later. X bar of 1 is 1,351. Standard deviation, that's going to be your S, of 109. Then I am going to analyze 10 bulbs for my second one. So on my N2, I'm going to do 10 bulbs. My mean for 2 is going to be 1,332, and my standard deviation for 2, 115. So, in the first part of my formula here, N1 is 16, so I'm going to do 16 minus 1, or just 15 if it's easier to type it in that way, times my standard deviation squared. So I'm going to have 109 squared plus N2 minus 1. N2 is 10, so 10 minus 1 is going to be 9, times my standard deviation squared, which is 115, so 115 squared. That's all going to be over N1 plus N2 minus 2. So 16 was N1, plus 10 was N2, minus 2 on the bottom. And then we have to calculate that value. Hit undo.
I highlight all these.
Okay, yeah, highlight that whole, whoops. This should be 10 minus 1 instead of 10 minus 9. 9 was my answer when I did the 10 minus 1. But yes, you could just put 10 minus 1 there. And then 115 squared. Otherwise, you could just, instead of doing this, you could just put the 9 and just put the 15 and not have to have the parentheses. Highlight over that whole thing, yep, and then divide it by, and then you're going to have 16 plus 10 minus 2. it equals. So we get 12,385, right? Now, we did all of that. We have to do the confidence interval formula. So like we did on the previous one, which I didn't leave myself a whole lot of space to write, we're going to do the mean ones minus the mean 2, plus or minus. This one's going to be a t-test. So t sub, we figured out it was going to be 0.05 because our confidence interval was 90. And then we're going to have the square root of behind that, but I have to smush it down there. The square root of my SP squared answer. That was that number we found over here. Times 1 over N1 plus 1 over N2. So on this problem, I'm just going to sneak it over here. Mean 1 was 1,351 minus mean 2, 1,332, plus or minus t sub 0.05, and then right behind that, but I can't fit it in, is my square root. My square root under there, I'm going to have the 12,385 times 1 over N1, which was 16, plus 1 over N2, which is 10. So this part should go right behind your T, like we did on our other confidence interval. Oh, yes, the T has to have the degree of freedom. My degree of freedom is going to be whatever you're getting for this bottom number here, which in this case I'd have 26 minus 2, which is going to be 24. So your degree of freedom is going to be that N1 plus N2 minus 2. 16 plus 10 minus 2, 24. I always forget the degree of freedom until I click on it and then it says you have to put the degree of freedom in there. Then I go, oh yeah, I got to do my degree of freedom. So, degree of freedom, it's that bottom part of this fraction, or N1 plus N2 minus 2. So, let's see if we can get all that in there on our calculator. Space on this paper, didn't we? I must have wrote smaller with my pencil. Alright, so first of all, if you clear that out, in parentheses, we've got our 1,351. That was the mean of our first sample.
Okay.
Then we're going to do minus the mean of our second sample. So minus our 1,332.
Where's that?
That's the mean of the second sample. Okay, close our parenthesis. Plus or minus, which is right above the 8.
Where's the 8?
So plus or minus there. Then we're going to do a t sub. So we're going to use the t here. And so we're going to use t sub 0.05 with a degree of freedom of 24. So just straight in that little second box, we're going to put our 24. So the 0.05 we got because we had a 90% confidence interval, which means we have 5% on each end. The degree of freedom of 24 we got by doing the N1 plus the N2 minus 2. So we took 16 plus 10, which is 26. 26 minus 2 is our 24. behind that, if we click up to the side again, so we're not down in that subscript, now we're going to do the square root part. Not squared, square root. There, yep, first one. Under the square root, we are going to take the answer that we got from here. This is not the answer here, it's just the answer to this. Whoop, that was that number. So we're going to use that number there. One, 2, 3, 8, 5. Yep, parenthesis. And then we're going to have 1 over 16, which was 1 over n. So 1 divided by 16. Click right behind the fraction. Oops. Look, right next to it. There we go. And then we're going to have 1 over 10, which was the n. Whoops, I forgot the plus sign. Undo a couple. Plus 1 over 10. There we go. Click behind the fraction, close your parenthesis, and now we should be able to hit equal. All right. So, my lower limit to 2 decimal places was, after all that work,
Negative 57175.
and we're just
75,
doing
sorry.
to 2 decimal places. So negative 57.75.
5. Yeah.
Is that what you guys got? I rounded off, so I have a slightly different answer because I was not putting the whole thing in the Alex calculator. All right, and then my upper limit was
95.75.
75. All right, 95.75. So it does give you some leeway in case of rounding. I rounded off my values to 3 decimal places, and so I have a slightly different number, but it will take it as long as it's pretty close to the answer because they know there's rounding issues. All right, so this is kind of a long one because we have to calculate this s² or sp squared in order to put into our confidence interval formula. Squeeze number 8 here. It says, the University Data Center has 2 main computers. The center wants to examine whether computer 1 is receiving tasks that require processing times comparable to those of computer 2. A random sample of 12 processing times. So N1 is going to be 12. Showed a mean of 60 seconds. So my mean one going to be 60. With a standard deviation of 19 seconds. So my S1 going to be 19, right? Computer 2. Well, a random sample of 9 processing times from computer 2. So N2 we're only going to do 9 processing times. Shows a mean of 50 seconds. So X bar 2 is 50 with a standard deviation of 18 seconds. And this one again, we're going to use a 90% confidence interval, so we know we're going to do T sub 0.05, right? When we do our degree of freedom, we're going to take N1 plus N2 minus 2. So if I do 12 plus 9 minus 2, my degrees of freedom would be 19. All right, so we have to start off with our first formula when we did our SP squared formula, that very first one. So in our first formula, the first number was n minus 1. You can either put in 12 minus 1 or just do 11 because we know that 12 minus 1 is 11, right? 12 minus 1 times the standard deviation squared, so my standard deviation is 19. Plus N2 minus 1. So again, you can either type in 9 minus 1, or if it's easier, you know 9 minus 1 is 8, right? Times the standard deviation squared, so the 18 squared. Now we now know the bottom number is going to be this value here. So again, you can either put in 12 plus 9 minus 2, or since I figured it out for my degrees of freedom, you can just type in 19 if you prefer. I'll write it out the long way, but you could just put in the 19 since we figured that number out already. And that would make it easier to get it typed in if you did that, some of those calculations ahead of time. So 11 times 19 squared plus 8 times 18 squared divided by 19 would be the quick way to type that in. And this says carry your computations to at least 3 decimal places. This one you're going to have to round off. It doesn't come out nice. Yep. 345.421. You can carry that out more if you like, but you have to have at least 3. Again, you'll get some slightly different answers depending on where you round, but Alex adjusts for that and knows that it's okay. Now that we found that, now we got to do the confidence interval formula. So on our confidence interval formula, we're going to start by subtracting our 2 mean values. So we're going to take 60 minus 50. Then we're going to have the plus or minus, and then we're going to do our t. So t sub 0.05 with a degree of freedom of 19 we already figured out. And then we're going to do our square root. And under our square root, the number that we found here goes first, 345.421. And then in parentheses, 1 over our n value plus 1 over our other n value. So 1 over 12 plus 1 over 9.
Okay, I'm stuck.
Oops. Unstick you.
Okay, what do I do?
You didn't get your parenthesis there at the very beginning. Let's just clear that out and start over. Yeah, close that. All right, so parenthesis first. And then the 60 minus the 50. Whoops, 60 minus 50. Oh. Just slow down. It's okay. Parenthesis 60 minus 50. Oops, the 5 didn't go. There we go. Close your parenthesis. Plus or minus t sub 0.05 with a degree of freedom of 19. And click up to the side, put our square root symbol. Square root, not squared. There we go. And then we're going to have the 345.421. Parenthesis. 1 divided by 12. Click behind the fraction. Plus 1 divided by 9. Click behind the fraction. Close that parenthesis. It equals. And we get.
Mine won't let me click the equals button.
Oh. What do we got going here? Okay, that all looks like it's there. Don't see anything weird there. 60 minus 50 plus or minus, that looks good. And we have all our parentheses. Oh, it's because the parentheses is on the outside instead of underneath the square root. Back it up. And then click right behind that 1/9 and then close your parentheses. Now, it lets us do it, okay? Yes, you'll have to practice using your calculator for sure. So number 8, my answer is?
Negative 4.17.
Yep.
20, and the second one's 24.17.
All right, we're going to leave off there. Next time we'll try to get caught up, but these are really long problems, so like I said, I'm not going to try to kill you too badly, although we missed 6 hours of class with our 2 snow days, and I'd like you to at least do the stuff that they do at other schools. So, we'll get there. I'm going to write myself a note, but if I forget, we left off on number 9. Start here. Try to be here at 2 o'clock next week so that we can get started right away.
Okay.
So again, on these ones, I've written down the formula. We had to find the SP squared by taking N1 minus 1 and the standard deviation sub 1 squared, N2 minus 1, the standard deviation squared. On the bottom is the degree of freedom, which is the N1 plus the N2 minus 2. Once we found that number, we plugged it into our formula in order to find the confidence interval on this one. And so if you're not logged into Alex, you'll need that in order to do our calculations once we get there. So, it says managers of an industrial plant want to determine which of 2 types of fuel, gas, or electric is more cost efficient measured in cost per unit of energy. Independent random samples were taken of plants using electricity and plants using gas. These samples consisted of 11 plants using electricity, so N1 is going to be 11, which had a mean cost of $50.70. So X bar 1 is going to be my mean cost, $50.80, and a standard deviation of $8.67. So S1 is going to be $8.67. My second one, we are going to do 15 plants using gas. So N2 is going to be 15, which had a mean of 50. Whoops, I put the wrong mean on the first one, didn't I? When you go back and forth, it's sometimes hard to see. My first mean was $50.70 with standard deviation of 867. My second one has a mean of $50.80 with a standard deviation. So S2 is going to be $7.98. Assume that the populations of costs per unit are normally distributed for each type of fuel, and assume that the variances of these populations are equal. Construct a 90% confidence interval for the difference between the mean 1 and the mean 2, and then for the plants using the electricity. Carry your intermediate computations to 3 decimal places. Round your answer to at least 2 decimal places. So, we said first of all that if I had a 90% confidence interval, that our 90% was in the middle, right? And that we would have 5% on both ends. I hope you know how I got those. So here when we do this, 0.05 is going to be our T sub value there since we have 5% on both ends, right? So in the first part of our formula, when we find our SP squared, we are going to do N1 minus 1, so 11 minus 1, times the standard deviation squared, so 8.67 squared, plus N2, so 15 minus 1, times its standard deviation squared, 7.98 squared, and then we're going to divide that by the degree of freedom, which I'm just going to figure out over here. I would take my 11 plus my 15 minus my 2, because I need that when I do my T anyway. That would give me 26 minus 2, which is 24. So I'll just put a 24 down there on the bottom. And you can either use the Alex calculator for that or your regular calculator since we don't have any of the T stuff. But if you calculate that out, we're going to carry that out to 3 decimal places. Yep, 68.467. So now we're going to use the second part of our formula over there to find the confidence interval there, the lower limit and the upper limit. So x bar, which is the mean of 1, minus x bar 2, which is the mean of 2. So we're going to have 50.70 minus 50.80 plus or minus t sub 0.05 with a degree of freedom of 24, which should be our same number we used under our fraction, right? Mm-hmm. And then we're going to have the square root of that number we just found, 68.467, 467 if I write the right number down, times 1 over n1, which is 11, plus 1 over n2, which is 15, and that's the formula that I'm going to type in to find my confidence interval. I'm just wondering where you had been. We're on homework 18. We didn't quite get it finished last time because they came in and did a survey. So we got a little behind. Yep, we're rounding to 2 decimal places on our final answer. So our lower limit should be negative 5.72. Our upper limit is going to be 5.52, exactly. So 2 different formulas that you have to do when you do those ones. First, I like to find the SP squared using this formula. Then I can do my confidence interval formula and get my 2 answers.